Shift workers seem to age faster. They have higher rates of dementia, cancer, and heart disease. Now, researchers working on fruit flies may have uncovered at least part of the reason why. Some of the genes that are controlled by the body clock are stress responders, and they ramp up their activity in aging flies. Findings from scientists at Oregon State University were reported in Nature Communications today, and they raise the possibility that if you tamper with your body clock, you may also be tampering with anti-aging defenses. All organisms, even bacteria, march to a circadian rhythm. In mammals like us, the body clock is set each morning by sunlight, which synchronizes the activity of cells all over the body. Like a maestro telling the cells to play in unison, says Jagajibul Tawaz, a senior author of the study. And as night falls, the clock mechanism releases melatonin from the brain's pineal gland. These rhythms don't just make us sleepy at night. A key function of melatonin, many organs show a diurnal change in their function. The way we metabolize food, for instance, is very different at 2 a.m. compared to 2 p.m. You're more likely to store it as fat at night. So is the way we store memories. Hundreds of genes change their activity according to a circadian rhythm, but researchers had never tested how their performance changes as animals age. We had assumed that because the sleep cycle tends to be disrupted during aging, that they would tone down, says Oliver Rawashday, a chronobiologist at the University of Queensland. So Jibul Tawaz and her collaborator, computational biologist David Hendricks, got a shock when they tested to see what happened as flies aged. The entire set of genes was monitored every 4 hours in both young and old flies. Some of the circadian rhythm genes not only kept up their rhythm in old age, their performance went into overdrive. Others that had never been rhythmic before became so in old age. We didn't believe the findings at first, says Jibul Tawaz. Dubbed late life cyclers, LLC, the genes also soared when young flies were exposed to oxidative stress. Taking a closer look at the function of some of them, Jibul Tawaz recognized a common theme. Several of them coded as heat shock genes whose function is to protect proteins from damage during stress. These are just what you'd want to mitigate the ravages of aging, where levels of damaged proteins rise. In Alzheimer's and Parkinson's disease, for instance, misshapen proteins clump to form toxic deposits. Flies kept in continual darkness didn't activate late life cyclers, says Jibul Tawaz, but why should these anti-stress genes be linked to the body clock? Jibul Tawaz guesses that stress resistance requires the cells of the body to play in synchrony. Indeed, in human cancer cells, the level of some of these LLC genes does not cycle, they are constantly high. So does the poor timing of LLC genes explain the ailments of shift workers? It's a hypothesis we have to test, says Jibul Tawaz. She is now looking at the effects of interfering with the genes in flies and mice. It's an interesting hypothesis, says Shantharajarathnam, a sleep researcher at Monash University, but he points out there are other reasons shift workers compromise their health, such as lack of sleep or eating at the wrong time. When you eat at 3 a.m., the way you handle your glucose and triglyceride levels is impaired, she notes. Nailing the hypothesis may take some time. Meanwhile, Jibul Tawaz makes sure she resets her LLC genes by popping a melatonin pill when she switches time zones, 1 mg taken sublingually at bedtime.